Hello, welcome to Fundamentals of Acoustics. Today is the 5th day of the 11th week of this course, and today and tomorrow we will talk about a different concept in context of acoustics, and that is known as loudness. That is known as loudness. Now, loudness does not double if PRMS doubles. The first thing to note that if I double the PRMS, loudness does not double. What is loudness? It is a perception. So, if you double the pressure and you ask the person, has the sound gotten doubled? He will say no, it has not doubled. Second thing, loudness does not double if dB gets doubled. Okay, if dB gets. So, you are playing initially a sound at 40 decibels and you ask the person that when you double the sound decibel level to 80, you ask him, has the sound doubled? He will say no, it has not doubled, it has gone up by much higher factor. So, loudness, and this is based on perception. So, this is a perception thing. This is a perception thing. So, it is an attribute of auditory sensation. It is an attribute of auditory sensation. And there are two terms in context of loudness which will help us quantify whether loudness has doubled or not. Okay. So, there are two terms. The first term is loudness level. This is one term. Okay. And the second term is loudness itself. So, please note, loudness level and loudness, they mean two different things. Loudness level and loudness, they mean two different things, and we will discuss that, but it is important. So, these are not the same, they are not same in engineering world. In regular language, we may mix them up, but when in engineering sense, when I say loudness level, it means something, when I say loudness, it means something different. So, first we will talk about loudness level. Okay. What is loudness level? So, first we will define it. It is the SPL, sound pressure level, of a 1000 hertz source which sounds as loud as the sound being heard. I will explain this. So, consider a bird. So, we will make this as a bird and it is producing some sound. And I want to say what is the loudness level of this bird. So, the question is, what is the loudness level of this bird. Now remember, this bird is not producing its sound at 1000 hertz, it may be something different, 1700 hertz, 2000 hertz, 5000, I do not know. But it is producing every time it talks or it tweets, let us say that it produces the same loudness level. Okay. So, the question is, how do we say, how do we measure its loudness level? Actually, what is the loudness level? I missed this term. What is the loudness level of this bird? This is the question we have to answer. Okay. So, what do? We say, okay, you listen to this bird and then the next speaker and you produce a 1000 hertz tone. And in step 1 you produce a 1000 hertz tone at 50 decibels, and then you ask the listener, is this tone as loud as the bird? The answer is no. So, you ask him, is the bird louder or lesser? So, he says that bird is louder. So, the next thing is you do 55 decibels, again 1000 hertz tone, and you ask him, is this tone as loud as the bird? He says no. So, you go up further. So, you go to 60, 65 and maybe at 70 the person says that yes, this tone is as loud as the bird. So, then the loudness level in this case is equal to 70 dB. The level of sound pressure level, right, corresponding to 1000 hertz tone. So, remember 1000 hertz tone is a sacred number, it is a reference number in measuring loudness level. The level of sound pressure corresponding to 1000 hertz tone, which is perceived to be similar as that of the sound in being heard, which is that of a bird, that is called loudness level. So, in this case it works out to be 70 decibels. Okay. So, let us look at a graph. So, what is loudness? Loudness is, so this is, we are just recapping, it is an attribute of the auditory sensation. What is auditory? Whatever we are listening. Auditory sensation of a sound ranging from quiet to loud, and loudness level. So, it is expressed as Ln. It is the SPL, sound pressure level of a 1000 hertz tone, which sounds as loud as the sound in question. And this is the same example. If a bird is chirping that it feels as loud as a 1000 hertz tone at 70 decibels, then we say that its loudness level is 70 decibels, or actually the actual unit is fons. So, we say that the bird is at 70 fon level. Okay. The bird is at 70 fon level. Suppose there is a drum and we are playing it and we want to measure its loudness level. Then we hear the drum and then we produce a which tone? 1000 hertz tone and keep on increasing it, and suppose we perceive that at 80 decibels of the 1000 hertz tone it sounds as loud as the drum, then we say that the drum's loudness level is 80 fons. So, unit is fons. Okay. Now, this loudness level, it depends on three things. It can change with frequency. Our reference is always 1000 hertz, but at lesser frequencies loudness level goes down significantly. It can change with SPL, and it also influenced by duration of sound. Okay. Higher frequencies sound louder. Let us look at this graph. Okay. So, on the x axis I have frequency, and on the y axis I have Ln. I have Ln. So, what does that mean? Let us consider this pink graph. This pink graph. So, and let us start at 1000 hertz. So, that is my point, 1000 hertz. So, at 1000 hertz, and let us say at 1000 hertz this pink thing corresponds to 40 fons, okay, 40 fons. Why? Because at 1000 hertz the decibel value is 40. So, at 1000 hertz fon equals SPL. So, it 40 SPL, 40 decibels and also 40 fons, both of them are same at 1000 hertz. Now, suppose I play some sound at, let us say 20 hertz, which is this point, then I have to play it at 90 decibels. I have to play it at 90 decibels so that it sounds same as a 40 fons. And what is the reference for that 40 fon? 40 decibels at 1000 hertz. Okay. In a sense, this curve is inverse, not inverse, a mirror image of what? A weighting curve. It is not exactly same as A weighting curve, because this is a little more accurate. While we are doing A weighting, we have smoothened some things so that calculations are important, but this is more precise, this is more precise. So, but A weighting, if I just take a mirror image around this axis, then the A weighting curve will look similar to this, okay. So, this is one thing. So, what we see is that the loudness level changes. I have to add more and more decibels for the sound to sound as loud as it sounded at 1000 hertz as I reduce my frequency, right. So, as my frequency goes down, I have to produce more decibels to make it sound at the same level at 1000 hertz. This is one thing. The second thing is that as you go up in frequency, no, not up in frequency, so this is your decibel level, right. So, as you go up in the decibel level, this change is not that much. See up to 40, 50, 60 changes are similar. The difference between these two curves and these two curves are same. But what happens? As I go above 100 decibels, this curve becomes flatter. As I go to 130, it becomes even more flat, right. That is why in last class when we were talking, above 100 decibels, the weighting curve starts shifting and we go for which weighting? The C weighting, but most of the times because we do not use decibels in excess of 100, we do not worry about it. So, in terms of weighting, most of weighting is used in most of the situations, very rarely we go for C weighting. But when we are talking about loudness contours, we see that as I reduce the frequency from 1000 hertz to downwards, I have to add more decibels if we want that it has to sound as loud as at the reference frequency, which is 1000. And also if I increase the overall decibel level, and if the decibel level is in particular more than 100, then this compensation, these loudness contours become somewhat flatter, right. See here this is at 0, it is very steep, but at 100 it is much more flat. So, this is the second important observation. And the third thing is that this loudness level also depends on the duration of exposure of sound, but that is something we will not talk today. But in general, loudness level, it depends on frequency. We have seen that it also depends on SPL, and the third thing which we have not discussed, but it is important to be aware of, is it also depends on duration sound, and the unit of loudness level is fon. Okay. So, that concludes our discussion for today. What we will do tomorrow, we will discuss another concept, and so what we had said was that we measure loudness in terms of two attributes. One is loudness level, and the unit of loudness level is Fawn, and the second thing is loudness. So, we will discuss this loudness as a concept in tomorrow's lecture. So, till that, have a great day and we will meet tomorrow. Bye.